Good afternoon, everybody. How are we doing? It's Thursday. It's about to be the end of the second week of the second semester. How are we doing? All right. Good. Close to the end of the week. It's almost Friday. Don't know if y'all have any classes after this. I hope not, because that's late. I don't do late classes. Let's get started. Little easy warm up. First question, you have to determine whether each of the following statements is an observation, hypothesis, experiment, or conclusion. So you can put O, H, E, or C in the chat. Letter A. Blind taste testers rate the flavor and texture of tomatoes grown in a greenhouse and tomatoes grown outdoors in a patch of soil. What you thinking? Observation, hypothesis, experiment, or conclusion? It's an experiment. So somebody's setting up an experiment here. What about B? Tomatoes grown in soil taste better than those grown in a greenhouse. So I would say that you can put observation or hypothesis in this case. It's not exactly a conclusion, but I would say observation or hypothesis. You can say, it seems like this always tastes better, and that would be an observation. Or, I think this is what's going on here. So either one of those would be acceptable here. What about C? 87% of tasters consistently rated outdoor tomatoes as tasting the best. Yeah, that one is pretty clear cut. It's a conclusion. What about the second one? You got to write this number in scientific notation. Coefficient should be 4.15. We're going to have a negative power of 10 because this number is definitely smaller than 1. 1, 2, 3, 4, 5, 6, 7. And always have your units. So it's 4.15 times 10 to the minus 7. Questions on these? Okay. Good. This is just a little review from last week. Today we're going to start Chapter 2. Chapter 2, we spend a lot of time building up the knowledge base for doing conversions. If math is not your jam, this is one of those chapters that you want to start early with the homework. The Chapter 2 homework is broken up into 2 pieces. So this coming Wednesday, next week, you have homework due that covers what we're going to get through today. The following Wednesday, it will be the remainder of the chapter. Don't get behind. Get started early. This homework might take you a bit. All right. We're going to start off with measurements and exact numbers. Hopefully you got a chance to watch the videos. If not, I'll try to catch you up as best I can, but we can't spend the whole time doing lecture because then we won't be able to do any practice. So measurements are just that. They're measured numbers. And they have a certain number of significant figures. So we use sig figs. With exact numbers, it's things that you can count. It could also be a definition. Like 8 ounces, 8 fluid ounces are in 1 cup. That's a definition and that's exact. So with that said, here's what we're going to do for this exercise. For each of these numbers, you want to classify it as a measurement or an exact number. For all of the measurements, write how many sig figs you have in the measurement. So I'll write out those instructions, and I'll give you a couple minutes to do that. So label each as measurement or exact. For the measurements, also the number of sig figs. We clear on what you need to do? Alrighty. Then I will give you a couple of minutes to get a head start, and then I'll start going over them. Let's get started. If you're not finished, that's okay. You can let me know if we get to one where you're like, wait, didn't do this one. For the first one, is it a measurement or exact number? You could put M or E in the chat. 80.5 centimeters. Yeah, that's a measurement. It's a length. How many sig figs? Yeah, there's 3 in this one. So we see a 0 here. That 0 is sandwiched between 2 non-zero digits. So that will always be significant. Next one, we've got 12 drops. Measurement or exact number? This one is an exact number, so we don't care about significant figures here. Next one, 560 deciliters. Yeah, this one's a measurement. How about them sig figs, though? How many do we have? Oh, we see a mix. So some say 3, some say 2. There are 2 sig figs here. This 0 at the end is a placeholder 0. So a 0 at the end, when there's no decimal, not significant. And it should say zeros, because if there are more than 1, then none of those are significant. So just to show that again, 560 deciliters, 5,600 deciliters, and 56,000 deciliters. These all have 2 sig figs. Is that clear to everybody? Okay. What about the last one? We've got 94.360 milligrams. Measurement or exact number? Yeah, this one's a measurement. It's a mass. How many sig figs? I agree. We've got 5 sig figs here. So that 0 at the end is significant when it's a decimal number. So that's the rule there. Zeros at the end of a decimal number are significant. Any questions on the difference between measurements and exact numbers or sig figs, counting sig figs? We'll get some more practice in as we go along anyway. So now we're going to combine sig figs and rounding. Does anybody need me to go over the rules of rounding? Don't be shy if the answer is yes, because I can do one of these examples with you. Okay. Now I want you to do this problem. Round that number 3.1457 grams to 3 significant figures and then 2 significant figures. We're going to do another one of these after this that will test the placeholder zeros. So this one will get you warmed up, and then we'll do another. Let me know if you have questions. I'll give you 1 minute to do these. Okay. So what do we get for A? If we round that number to 3 significant figures, with 3 sig figs, the 4 is going to be the last retained digit. You look at the 5. That is definitely 5 or greater. So we increase the 4 by 1 to 3.15. Don't forget the units. Those are grams. What about the second one? 2 sig figs. We'll do that in a different color. This time the 1 is the last retained digit for 2 sig figs. And we're looking at the 4. That's 4 or less, so we're just going to keep the 3.1 and toss everything else out. Let's try another one. This time, we've got a much bigger number, 9,876.22 kilometers, and I want you to round that to 3 sig figs and 2 sig figs. I'll give you another minute, and then I'll check back in. All right, y'all, talk to me. 3 sig figs. How do we round this? Okay, so Remember those placeholder zeros. For 3 sig figs, we can get rid of this line here. That means that we're looking at the 7 as the last retained digit. The 6 is definitely 5 or greater, so we need to increase that 7 to an 8. But 988 is not the same as 9,800 something. Those two numbers aren't even in the same ballpark. We have to add a placeholder 0. That 0 is not significant, but it gives us the right place values for the other numbers. Any questions about that? Let's see what you got for the next one then. Since you gotta add placeholder zeros. Yeah. This time we're looking at that 8 as our last retained digit. The 7 tells us to round that 8 up. 9,900. And that's kilometers. Those underlined zeros are placeholder zeros. So don't forget that when you're doing your homework. Then placeholder zeros will try to come for you. Don't let them. Questions? Do you want another practice like this? Or are you ready to move on? All right. Now we're going to move to addition and subtraction with sig figs. I will go through an example with you, and then I'll let you guys do the rest of them. I should have numbered these. Okay. So I'll do number 1, just to get everybody on the same page. And then I'll let you guys do the other 3, and then I'll check back in. So with sig figs, we have to use the number of decimal places for addition and subtraction that represents the measurement with the fewest decimal places. So let me write that out. Report your answer using the same number of decimal places. Emphasis on that because that is definitely different as the measurement with the fewest decimal places. All right. For number 1, we've got 2 lengths. Which one has more decimal places to the right of the decimal? So we're talking about on this side over here. The top number or the bottom number? The top one has more, all right? So it's got a little bit more detail than that bottom number. I like to draw a dotted line that shows me which places I'm keeping and which places I'm ditching. So everything to the left of the line, I'm going to keep. Everything to the right of the line, I'm going to ditch it. You can still use your calculator here. I'm just going to do it by hand. So you add everything as normal. Everything on the left-hand side of this dotted line I'm going to keep, which means that I need to round this last 7. I'm going to look at the 6, and that's definitely 5 or greater. So my actual answer, which I'll write in red, is 177.8 centimeters. You ready to do the rest of these problems on your own? Or do you need me to go through that example again? Okay, so let's try one more. I'll do the second one. And if you want to work ahead, you can. For the second one, which one of these numbers has the fewest decimal places to the right? So we're looking at the decimal, looking to the right of the decimal. Which one has the fewest places, the top or the bottom? The top one. So that means we can only report up to this decimal place. What place is that? That 2. The 10th place. So our answer can only have up to the 10th place. We're going to keep everything over here. Everything over here, we're going to get rid of it. The only thing we use it for is rounding our number. Now, normally, when you're doing subtraction, you fill in those zeros and then you go on about your day, right? But here, that would actually harm you because it might fool you into thinking that you can just report the number as is. So don't do that. Anybody get an answer that they want to share? You can either put in the calculator answer, or you can tell me what you think the rounded answer is. So I'll write in the calculator answer, 2385.751. That's the calculator answer. I need to round this 7. I'm going to look at the number next to it, the 5. I'm going to go up 1. So my answer will be 2385.8. And don't forget units, grams. Now I'll release you guys. You do number 3 and number 4. And then I'll check back in. I'll give you about a minute and a half. Okay. So what about this first one? Oh, sorry, the third one. The first one that we're doing, but it's number 3. Oops. Whoops. What are you doing? Okay. So I'll walk through it real quick. There's my dotted line. So I know that I have to round the hundredths place, whatever that is, after I add it up. Don't let it be confusing that there's a 0 here. What we're looking at is the number of decimal places to the right. And there are 3 decimal places in this bottom number and only 2 decimal places in the top. So we have to cut it off at the hundredths. We're going to round that 5. We look at the 2. Just keep it the same. 4.55 centimeters. Oh, excuse me, 4.45. Yeah, that should be a 4. There we go. All better. For number 4, draw that line. You have to keep everything up through the tenths place. When you do the math, it's 83.327. We're going to keep that 3 in the tenths place. We look at the 2. It is 4 or less. So our answer is 83.3 seconds. Okay. So those of you who were participating, it seemed like y'all got it. But there's quite a few of us in here, and I certainly didn't get 33 answers. So if you're stuck, this is the chance. Let me know. If you're good and you're like, I'll just let it go, then that's fine. But you can always speak up. Okay, you want to do one more? Then here's what we'll do. Let me pull out a different color. We'll do some combining. We'll take the 153 and we'll add it to we'll make that 1 centimeters. I'm going to move that other answer over a bit. So we'll call this one number 5. When you have your answer, you can go ahead and put it in the chat. I'm going to put it in my calculator because I just made this one up. So we have to cut this off at the hundredths place, right? Because the top one only has 2 decimal places. Bottom one has 3. You add it up. That 0 is the last one that we keep. So we look at the 9 to see what we do, and we have to round up. There. Does that help? Because we got to move on now. Good. No problem. Yeah, always speak up. I'm here for y'all. Now we need to do multiplication and division. It gets a little bit more interesting here because with multiplication and division, whatever we do to the numbers, we also have to do to our units. So I will do an example with you, and then you'll try an example, and then we'll do it that way. So this first one, I'll review the rule of how we do this, right? Just in case you didn't get a chance to see the video. So with multiplication and division, what you want to do is report your answer using the same number of sig figs this time as the measurement with the fewest sig figs. So that is the difference. Adding and subtracting, we care about decimal places. Multiplication and division, we care about the number of sig figs. I'll go ahead and number these so we can refer to them. For number 1, we've got two measurements, 23 feet and 502 feet. I want to know how many sig figs are in each of these measurements, the 23 and the 502. There's 2 sig figs here, 3 sig figs here. With our rule, when we multiply, we have to use the same number of sig figs as the measurement with the fewest sig figs. So how many sig figs should our answer have? Right. I'd recommend that for your homework and for exam questions where you're doing this kind of thing with sig figs, that you figure out how many figures or how many decimal places your answer needs to have before you do the actual math. For whatever reason, when students do the math first, sometimes it can be a little bit harder to be like, oh, wait, I have to do sig figs. So if that seems to be you, then figure out the sig figs first. If you're all right with doing it the way you're doing it, keep doing it. But that's just a tip. So when you multiply these two numbers together, what do you get? Well, we need to report this answer with 2 sig figs. What does that look like? I'm going to put my answer in red here. I agree, it's 12,000. But we're missing something. We're missing units. Our units aren't just feet because we're multiplying. 2 times 2, it's 4, but it's also 2 squared. Yeah, so feet times feet gives us feet squared. That's our unit. So when you think about it, when you were in elementary, maybe not elementary school, middle school maybe, is when you started doing areas and stuff like that. When you're multiplying to figure out the area, the unit is feet squared or inches squared. That's because you're multiplying two measurements. Inches times inches or feet times feet. Yards times yards. It's the same thing here. So when you're doing your homework on mastering chemistry and when you're doing the quiz, make sure that when you're multiplying and dividing that you pay attention to the units. With that said, try number 4. I'll give you a minute and you can put your answer in the chat with the correct number of sig figs and everything else. And then I'll go over it. So 1 minute and I'll check back in. As you get your answer, you can put it in the chat. If you haven't gotten an answer yet, that's okay. So for the multiplication of the numbers, you don't really need a calculator. You're just moving the decimal place. But we need to worry about sig figs and units. In 100 meters, how many sig figs do we have? We've only got 1 sig fig here. These other 2 zeros are placeholders. Remember the rule. Zeros at the end of a number without a decimal place are not significant. So 100 without a decimal only has 1 sig fig. However, 82.7 has 3 sig figs. So when we report our answer, we only have 1 sig fig. We look at the 2, that's 4 or less. So our number answer is 8,000. The units, we're doing meters times meters. That's equal to meters squared. The other way that you could write number 1 and number 4, those answers, is to use scientific notation. So for number 1, you can write 1.2 times 10 to the 4th feet squared. And for number 4, you can just write 8 times 10 to the 3rd meters squared. Same thing. On your homework, it will usually specify whether or not you should use scientific notation or not. Generally speaking, scientific notation is going to be easier than using a decimal. How do we feel about these multiplication problems? The math part isn't hard, but how do we feel about the units and the sig figs? Alright, now we got to do division. Same rule. We have to use the same number of sig figs as the measurement with the fewest sig figs. So let's start with number 2. We've got 75 centimeters cubed and 5 centimeters. How many sig figs should our answer have? Right. So our answer should have 1 sig fig. If you do that math, 75 divided by 5, you get 15. But we have to do units. Centimeters cubed. What that really means is centimeters times centimeters times centimeters. Right, it should be centimeters squared. So if we take all of those centimeters, that's the top units. The bottom only has centimeters. In math, when you've got an X on the top and an X on the bottom, or a Y on the top and a Y on the bottom, you can cancel it out. So that's what we're doing here. But only if you have the same unit in both the numerator, which is the top number, and the denominator, the bottom one. So if you've got the same unit in the top and the bottom, you can cancel it out. Are we good with that one? Then go ahead and do number 3. And don't forget to include units. Remember that you cancel only if you have the same unit. So if you don't have the same units in the top and the bottom, you want another example? Okay. Then I can do number 3, and then I'll give you something else to try. All right. So for our sig figs, how many sig figs should our answer have? Yeah, it should only have 2. Each of these numbers has 2 sig figs. That 0, that's a placeholder. We do the math and we get 0.511111 repeating. Well, that's pretty easy to round. That's 0.51, that's 2 sig figs. With our units, we've got feet on top and seconds on the bottom. None of that cancels, so you just have feet per second. Now I'll give you a problem. Now these units don't really mean anything, but it's just in order for you to practice. So that's number 5. I think you guys get the sig figs, so I want to make sure that you understand the units part. You are on it. I'm going to give everybody else a few more seconds to try to catch up. If you got the same answer, you can put same. But don't lie. If you still don't get it, let me know. Okay. Oh, you're good. You're good. Don't hold back your greatness, all right? As far as the units, we can cancel out the seconds. We can also get rid of the meters on the bottom. We still have 1 meters at the top. Both of these measurements have 2 sig figs, so our answer should have 2 sig figs. So you can simplify those units, and sometimes that's what will trip you up on the mastering chemistry homework. So don't let it. Does that help with more examples of the division? Good. Then let's move on. Y'all are doing great. So this is the part where you'll need the prefixes chart. And I forgot to send y'all an announcement saying, hey, make sure you grab that, or like have the lecture notes open. So if you need a minute, go to Blackboard to the course content and get the lecture notes from chapter 2, the first video. And that has the prefixes. There's 2 tables for prefixes for the metric system. While you do that, I'll try to catch everybody up, just in case you didn't get a chance to watch the video. We're talking about the metric system and units of measure. And we're talking about eventually kind of how to convert from one unit to another. We can do that within the metric system, and it's pretty simple. We can also do that between systems. So we use the English or the imperial system here. We can do conversions between English and metric. In order to do that, we have to use what's called an equality. And that just defines a relationship between 2 units. So when we're talking about the exact numbers versus measured numbers, I gave the example of 1 cup is equal to 8 fluid ounces. That's an example of an equality. It's the same thing, just 2 different units, cup versus fluid ounce. The charts that I put, it's actually one big chart, but I split it up. We can use that information to do the same thing within the metric system. And I'll give you an example. Let's say that I had 1 deciliter. That's what that little d is. That symbol means deci. When you're using the chart, you find deci and you see what number it says. It'll say something like 0.1, and 1 times 10 to the minus 1. It may also say 1 over 10. Those are all the same thing. So deci, the prefix, means 0.1. To fill in this equality, which equalities have equal signs. That's the way you can remember it. We replace the deci with the number that it means. So you write 0.1. And that completes the equality. 1 deciliter is equal to 0.1 liters. If you wrote 1 times 10 to the minus 1 or 1/10, those would all be correct. Same thing. Is everybody with me? So let's try to go through these, and I hope you have the chart by now. For A, we have 1 km. What does the K stand for? K means kilo. To fill in the equality, find kilo, and then you put in the number that it says. So what should I put here? How many meters are in 1 kilometer? (1,000 meters). I want you to do B and put your answer in the chat. You've got 1 milligram. How many grams is that? Yes. So 1 milligram is equal to 0.001 grams. You can also write these in scientific notation, and that would be perfectly fine too. For this last one, C, I've already given you the basic unit here. What I want you to do is figure out what prefix is this. Look at your chart and figure out which one means 0.01. Yes, it's a centimeter, so you'd fill in a C here. So let me know if you want more practice and we can do a couple more, or if you want to move on. But this is key to understanding the rest of the chapter. If you don't understand how to write equalities, then it's going to be a struggle. Yeah, we can do a couple more. Try to make some defined spaces here. So the top one, you'll need to fill in the number. The bottom one, you need to fill in the prefix. I'll give you a minute to look those up, and then I'll check in. Alright, did anybody get anything for the first one? We've got 1 megagram, that's a capital M. How many grams is that? That's milli. 0.001 is milli. The capital M is mega. So that increases. Should be much bigger than that. Remember that the chart is split up over 2 slides. There's one that shows prefixes that increase and one that shows prefixes that decrease. Yeah, it should be 1 times 10 to the 6. That's why I like scientific notation. I ain't got time for them zeros. And what about E? Did we figure out the prefix that goes there? No. So 1 times 10 to the minus 12. That's a 1 with 11 zeros in front of it. Should be picogram. So that makes it smaller. Can everybody find pico on that chart? So this will definitely be on the homework. Make sure that you can do these types of problems. Your homework is always due on the Wednesday before class. So if you have questions, you can come to office hours on Tuesday. So get done what you can get done, and then bring your questions on Tuesday. I have office hours from 11 a.m. to 1 p.m. If you have class during that time, or you work, then hit me up as soon as possible and set up an appointment so that you can still get the help you need. So for time, we have to move on, but make sure that you understand how to do these. So we're going to do more practice with writing equalities, and we're also going to talk about conversion factors. So conversion factors come from equalities. They're just fractions. I'll do the first one. The first part is writing an equality. And we have to do that for meters and centimeters. The easiest way to do it is to start with the unit that has the prefix and say I have one of those. So I've got 1 centimeter. Then you can look up on your chart what centi means and fill that in. 0.01 meters. That's your equality. From there, we need to write conversion factors. And those look like fractions. So you take the 1 centimeter and make that the numerator. You put the 0.01 meters on the bottom as the denominator, and that's 1 conversion factor. There are 2 conversion factors for every 1 equality. You have the one that I just wrote and the reciprocal. You put the 0.01 meters on top and the 1 centimeter on the bottom. Order doesn't matter as long as you have both if you're asked for the conversion factors that you can write from an equality. So let me know if you're with me. If you need some more help, let me know. Okay. Then what we're going to do is I'll give you one that's similar to the one I just did. So we just did meters and centimeters. I'll give you another metric one that you can figure out. Grams and nanograms. You need to write the equality and then also write the conversion factors. I'll give you 2 minutes and then I will jump in. Okay, we'll get started here. I'm not going to ask you to put it into the chat because it would be kind of annoying to write. I don't want to do that to you. So I'll write it out and then I'll check with you to see if that's what you got. For our equality, we'll start with the nanograms because it's going to be easier to write it that way from the chart. If I've got 1 nanogram, you look up nano, and that's 1 times 10 to the minus 9 grams. You can just by show of hands, or you can say me. Let me know if you got it. If you didn't get it, you can say stuck or anything like that, and just to let me know. All right. So our conversion factors, that's the easy part. You take it and you make fractions. 1 nanogram over 1 times 10 to the negative 9. And then, don't forget our units there. And 1 times 10 to the minus 9 grams over 1 nanogram. Those are the 2 conversion factors. Okay. So the best thing I can tell you for writing the equality, if you're given 2 units, is to start by looking up the prefix. So you look up nano, and you find that. That's one of the ones that will decrease the unit size. And nano means 1 times 10 to the minus 9. It's a 1 with 8 zeros in front of it. So if I have 1 nanogram, like I wrote here, I need to figure out how many grams that is. Well, I just write equals the number that nano represents, which is 1 times 10 to the negative 9, followed by the basic unit, grams. Hopefully that explanation helps a little bit more. Does that help? Good. All right. Now we've got to do B and C. B, we're looking at percentages. So a percentage is a part over a whole, right? And when you see a percentage like 18%, that means 18 out of 100. But we need some units for that. So if jewelry contains 18% gold, we can say, for example, that 18 grams of gold out of 100 grams of jewelry. That's what that percentage means. That's a conversion factor. The other conversion factor is to just flip it around. There's a lot of black on this slide, so I'm going to switch it up a little bit so you can see the difference between the two. For our equality, it may look a little weird. Yes. I heard a hand go up. If you have a question, you can go ahead. If not, all right. For the equality, it's simply writing 18 grams of gold is equal to 100 grams of jewelry. It's the definition that defines what 18% is. Does that make sense? So I want you to try C. C is similar. It's not a percentage, but you're going to write an equality and 2 conversion factors. You've got 1 gallon of gas is $3.40. That's your relationship. So the equality hopefully won't be too difficult. Then you write the conversion factors, which are just fractions. I'll check back in about a minute and a half. Okay, we'll start with the equality. In the lecture video, I talked about, I think it was like the price of onions or something like that is $1.24. This is a very similar example to that. 1 gallon of gas is $3.40. 1 gallon equals $3.40. That's your equality. Your conversion factors we're just going to make those fractions. Does that make sense? Let me know if you're with me here. If you're ready to move on, let me know. If you got questions or you want to try another one, you can let me know that too. Then let's move on. We're going to start with conversions. Actually, this would be a really good time to take a short break so you can shake your brain out a little bit. We'll take a 5-minute break. It's about to be 3:30. So we'll break for 5 minutes till 3:35 p.m. Then we'll get back to it. All right, everybody. It is 3:35. We're going to get back to it. So far, we have covered measurements and exact numbers, counting significant figures, rounding, placeholder zeros. We also looked at writing equalities, learning the prefixes with the metric system, and writing conversion factors. So that's like 8 topics. There are some more nuances that you can get from the pre-recorded lecture that's on YouTube. What we're doing is kind of hitting all the big things to make sure that you've got the major concepts. There may be a few small details here and there that we're not covering in the live lecture. So just remember that. The goal of the live lecture is to do practice problems and see the things that you don't understand so we can work on those together and you can get some feedback. If we just spent the time with me lecturing at you and doing what I do in the video, 1, it would be very boring, and 2, it wouldn't be very effective. So the more you do before class, the more meaningful this experience can be. So thank y'all for participating, for answering stuff, asking questions. I love it. Really appreciate it. It makes the time go real fast. With that, we're on the last so we already covered mostly what I covered in the first video. Now we're going to start doing practice with doing conversion problems. We're going to do a couple of problems, and then next week we'll start again with doing some more conversions and finish out the rest of chapter 2. So here we go. I'll go through this first problem. If you want to go ahead and solve it on your own, that is perfectly fine. You're more than welcome to do that. However, I'm going to go through and kind of show you how I do these types of problems and mention the tips that I have for overall problem solving. So for this one, you're performing an experiment that requires you to measure 56 milligrams of sodium bicarbonate. Your balance reports mass in grams. How many grams of sodium bicarb do you need? Report your answer in scientific notation. Before I do anything, I will rewrite the question. In here, there's this big old paragraph of text. But the question is, I need 56 milligrams. What is that in grams? So it's just a conversion. What are we given, aside from the 56 milligrams? We know something about the relationship between milligrams and grams. Using that chart, we can write an equality. If I have 1 milligram, that's the same as 0.001 grams. I can write conversion factors. One milligram over 0.001 grams, and then flip it. Let me know if you're with me so far. All right, appreciate it. Now let's set up the equation. We're starting with 56 milligrams. That's why we went through all of this mess, because we need to take milligrams and make it into grams. To do that, we need to use one of these conversion factors. In order for us to cancel out the milligrams, we need to have a conversion factor with milligrams in the denominator. You can only cancel units, remember, if you have 1 in the numerator, the top, and 1 in the denominator, which is the bottom. Knowing that, which conversion factor should we use? A or B? We should use B. Milligrams are in the bottom, and now we can cancel. I recommend that you go through and just make sure that your units actually do cancel and you're left with the unit that you want. So I canceled the milligrams, and that leaves us with grams. And that's what our question is asking. So always double check, make sure your units are what you expect them to be. Now you can touch your calculator if you so choose. When you put that into your calculator, it will tell you 0.056. It's not going to tell you grams or anything like that. What you need to do is go back to the question and see, how am I supposed to report this? Obviously, I need units. But it says report your answer in scientific notation. So if you put 0.056 grams down on an exam or in your homework, it would be wrong. Even though it's the right number, it's not in the right format. How would I write 0.056 in scientific notation? The coefficient's going to be 5.6. And we're going to have a negative power of 10. 0.056 is less than 1. So that means our power of 10 is going to be negative. And then, of course, we can't forget the grams. That's why we did this thing in the first place, to figure out how many grams. That is our final answer. How does that feel? Do you feel like you can try something like that? And if your answer is, Dr. Hefner, no, don't want to touch it, you're allowed to say that too. Then I want you to try this one. How many milliliters are in 1.82 liters of water? Report your answer in scientific notation. Make sure that you write out your equality and your conversion factors, and then set up your equation. I'll give you 5 minutes and then I'll jump in and solve. If you have questions in the meantime, or you get stuck, let me know, because I'm literally just sitting here looking at my screen. I'm not going anywhere for 5 minutes. So if you need help, let me know. Okay, I'll get started here. But before I do, let me know if you finished the problem, if you need more time, if you got stuck. All of that information is helpful to me. So you can share your answer if you'd like. If you got stuck, that's fine. We'll get you unstuck. So if you did get stuck, where did you get stuck? Was it writing the equality, figuring out which conversion factor, or was it simply trying to figure out what is the question? Let me know where you got stuck. Okay. When you tell me where you got stuck, I can pay a little more special attention to those areas and help you so you don't get stuck in the future. So that's why I'm asking. Normally, this is the part of class where I can walk around and see what you're doing, ask questions, say, "Hey girl, how you doing? Hey, hey my brother, what's going on?" Right? But we kind of can't do that virtually. So this is my way of trying to do that. So thank you for sharing. I know sometimes it can be a little intimidating saying that you didn't get something in front of a bunch of people. But truthfully, you paid your tuition and you're here to learn. The way you learn is by admitting what you don't know so you can grow. Cool. So let's work on setting up the problem. How many milliliters are in 1.82 liters of water? Report your answer in scientific notation. We've got how many milliliters, and we've got 1.82 liters. Those are the two things of units that we've got. Our question is always going to be in the form of, for these conversions, something that we're given, a given measurement, is equal to some other unit of measure. What's the given measurement in our question? It's the 1.82 liters. That's what we were given. What unit of measure are we trying to figure out? Milliliters. That's the question mark. So there's our question. We've got 1.82 liters, question mark, milliliters. Now we've got to write an equality, and we need to relate milliliters and liters. If we're starting with the one with the prefix, right? So that's the easiest way to do it. You start by saying, I have one of these. I've got 1 milliliter. You can use the chart and look for the lowercase m. Remember, there's two M's. One's uppercase, one's lowercase. The lowercase one is what you want. When you do that, you'll find that M is milli, and it means 0.001, which is the same thing as 1 times 10 to the minus 3. We replace the milli. Let me use a different color here. So that red M is our milli, that's our prefix. And we need to write how many liters that is. Replace the M with the value you find on the chart. Now we have an equality. So for those of you that got stuck in particular, are you with me so far? Any aha moments? Okay. Now we've got to write those conversion factors. Now, as you practice this and you get comfortable, you may want to skip the step of writing out both of the conversion factors and just go straight from the equality to writing out your equation. If you end up feeling comfortable enough to do that, by all means, go for it. Otherwise, I encourage you to write out the conversion factors and then put your equation together. It's one way to help you make fewer mistakes because you have to write it multiple times and you have to look at it multiple times. So hopefully you'll catch the errors that you make. Those are our two conversion factors. I'm going to label these so that when I write out the equation, you can help me out and let me know which one of these conversion factors we need to use. When you're setting up the equation, you have to go back to your given information, and we're starting with 1.82 liters. That's our given. The next part of this is our conversion factor. Which conversion factor should I use to get from liters to milliliters? Is it A or B? It's going to be A. We need to have the liters in the bottom so that they cancel. And put the 1 milliliter on top. That will carry through. When you put this into your calculator, you're going to put, I'm going to do it in a different color. This is just to show you. 1.82 divided by 0.001. So that's what you enter into your calculator. When you have a number on the top, the numerator, you're multiplying. When you have a number in the bottom, the denominator, you're dividing. I just want to point that out. Your calculator should tell you 1820. Doesn't tell you any units or anything like that. Again, look back at your question. You have to report your answer in scientific notation. So that means 1.82 times 10 to the third milliliters. Now you'll notice that I left off the 0 there. The reason is, in our given information, we've only got 3 sig figs. That means our coefficient also has to have 3 sig figs. For those of you who went all the way through and got an answer, let me know if this is what you got. If you didn't, did you figure out where you went wrong? For those of you who got stuck, let me know if this helps you. It's a lot of questions. Okay, so you shouldn't get to the -3. If we're going from liters to milliliters, let's just think about this for a minute. Which unit is bigger, liter or milliliter? The liter is bigger. So when we take that liter and break it up into something smaller, we should get a number that's bigger than the number of liters. So if we've got 1.82 liters, the number of milliliters should be bigger than 1.82. In my other chemistry class, I like to talk about it in terms of pizza, because everybody knows pizza, right? If I have one pizza and it is sliced by someone who's been working there for more than a day, I will get 8 approximately even slices. A pizza is one big whole unit. A slice, much smaller. So if I've got 2 pizzas and I have to figure out how many slices that is, it's going to be a number that's bigger than 2 because a slice is only an eighth of a pizza. I've got 16 slices here. So if you're wondering whether your number is correct, compare the unit you start with to the unit that you need at the end. If you're going from a bigger unit to a smaller unit, let me write some of this down. It's all right. That's why we're here. If you're going from a big unit to a small unit, your answer is going to be bigger. If you're going from a smaller unit to a bigger unit, then your answer is going to be smaller. So that's where we're going to put conversions. I don't think I have any more after that yet. So we're going to be able to end a bit early this time. Don't worry. We're going to have more conversions next week. I didn't want to overwhelm you. I'm posting your Chapter 2 check-in today. It will be located in the course content in the Chapter 2 folder. I'll send out an announcement. But I want you to do that, and it is due the day after the Mastering Chemistry. So you can do your Mastering Chemistry, and then this is literally going to be 2 problems that you do and submit via Blackboard. I want to be able to give you some individual feedback. I always give feedback. I don't just give you a score. I give you feedback and tell you why I took off points. That way I can give feedback to those of you who don't necessarily feel comfortable with writing in the chat Maybe it takes you a little bit longer to get the concept, so you're just kind of taking it in. So these are my ways of getting to everybody. It also counts as participation. Yes, the check-ins are different from mastering. The check-ins are, so there's 10% of your grade from participation. That's the chapter check-ins. So we won't have them for every chapter, but for some of the heavier math chapters, I'll have you do a problem or two and submit it to me. So the way the course is set up, you'll always have your mastering due on a Wednesday if it's due that week, and the check-ins will be due on Thursdays. So the chapter 2 check-in that is going to be posted today will be due next week on Thursday by the end of the night. So the way that I grade the chapter check-ins, you get partial credit. So you won't get full points if you get it wrong, but you have to show all your work anyway. So if you show your work, you'll at least get a few points. You'll at least kind of pass, you know what I mean? And I usually will include a little bit of extra credit there. 10% of your grade is not a whole lot, but it is the difference between an A and a B, or, a C and a D. So that can really help your grade, actually. So that's the chapter check-in. You also, like I said, have mastering chemistry, just the homework for 2.1 to 2.5, which we covered all that. And then we started with the conversions, which is 2.6, 2.7. We're going to finish up with conversions next week, so you don't need to do that part yet. If you feel comfortable, you can try some of those or at least look at them, but that's not due yet. You've also got your first exam coming up. It will be available during the week of February 15th, but I wanted to ask for your input. Normally, I teach this class on a Tuesday, and then we can do exam review, and I give, Wednesday through Friday as the time window for when you can do the exam. We have class on Thursdays. So, when we finish covering chapter 3, and then the next week we have the exam, if I open it up on Wednesday, nobody's going to do the exam on Wednesday. Let's just be honest. I mean, if you feel like you would, let me know. But if we're doing exam review on the second day that the exam is available, nobody's probably going to touch it. So, the syllabus says that I will give you a 3-day window. But what I would like to know, if we just said that the exam will be available directly following class on Thursday, so that would be, let's say, Thursday at 5 p.m. all the way through Friday at 11:59 p.m. Is that enough of a window for you to take your exam? Absolutely. Mm-hmm. Okay, tell her to send me a course message on Blackboard, but she may need to reach out to IT or the registrar, because if it's a matter of there's an issue with her Blackboard account, then that's Aggie Help Desk. If it's a matter of something funky with, her registration for the course, it's the registrar. No problem. Okay. So, I will update the syllabus to reflect this change. Exams will be available so the week that the exam happens, the exam will be available the Thursday of that week at 5 p.m. and it will remain open until Friday, 11:59 p.m. So that gives you about a day and a half. I know some of y'all are probably night owls, so you can do your exam. The other option would be for me to open it up Wednesday and say Wednesday through Friday to give you some extra time. But you're at a disadvantage if you complete the exam before we do exam review. I don't want to put it on the weekend because the other Chem 104 classes will have completed the exam. And, I'm trying to make it so that it sticks to Monday through Friday for the exam. So speak now or forever hold your peace. If you're okay with Thursday at 5 through the Friday, then we're good to go. And I will reflect this, like I said, in the syllabus. Okay. I'll revise that, put it in the syllabus, and post it. So it'll say revised syllabus, and it'll have the date that it was revised, and it'll reflect that change. Other than that, we're done. So if you have questions, let me know. Otherwise, you're free to go.